Hi friends, welcome to my channel. In this video I will discuss some important question from AWS Solution Architect exam point of view. It will certainly help you to be successful in the exam. Please subscribe my channel for more contents on AWS. Question 1. An analytics company dealing with big data is seeking to store on-premises data in a POSIX-compliant file storage system on the AWS cloud. This data will be accessed only sporadically, typically for about a week each year. As a solutions architect, which of the following AWS services would you recommend as the most cost-effective solution? Options are 1. S3 Standard, 2. S3 Standard IA, 3. EFS Infrequent Access, 4. EFS Standard. Please pause the video and answer, and then check with me if you are correct or not. Hope you paused the video and noted the answer. The correct option is option 3 above. Please follow below explanation. Explanation. The most suitable option is EFS Infrequent Access. Amazon Elastic File System, Amazon EFS, offers a scalable, fully managed NFS file system that can be used with both AWS cloud services and on-premises resources. EFS Infrequent Access, EFS IA, is a storage class designed for files that are not accessed regularly, offering a cost-effective price-to-performance ratio, with storage prices up to 92% lower compared to Amazon EFS Standard. The EFS IA storage class costs $0.0 to 5 GB month, and it can be activated by enabling EFS lifecycle management for your file system and selecting a relevant lifecycle policy. Question 2. A company's systems administrator is planning to establish a highly available architecture for a Bastion host solution. As a solutions architect, which of the following options would you recommend as the solution? Options are 1. Create a public network load balancer that connects to EC2 instances serving as Bastion hosts managed by an auto-scaling group, ASG. 2. Create a VPC endpoint for a group of EC2 instances acting as Bastion hosts managed by an ASG. 3. Create a public application load balancer that connects to EC2 instances serving as Bastion hosts managed by an ASG. 4. Create an Elastic IP and allocate it to all EC2 instances acting as Bastion hosts managed by an ASG. Please pause the video and answer, and then check with me if you are correct or not. Hope you paused the video and noted the answer. The correct option is option 1 above. Please follow below explanation. Explanation. The appropriate choice is to create a public network load balancer that connects to EC2 instances serving as Bastion hosts managed by an ASG. The network load balancer is specifically suited for use cases involving low latency and high throughput workloads, with the capacity to scale to millions of requests per second. It operates at the connection level, Layer 4, directing connections to targets such as Amazon EC2 instances and containers within Amazon Virtual Private Cloud, VPC, based on IP protocol data. Incorporating Bastion hosts in the VPC environment enables secure connections to Linux instances without exposing the environment to the internet. Once the Bastion hosts are configured, access to other instances within the VPC can be established through Secure Shell (SSH) connections on Linux. Bastion hosts are equipped with security groups to ensure precise ingress control. It is essential to note that Bastion hosts utilize the SSH protocol, a TCP-based protocol functioning on port 22, and they must be publicly accessible. Therefore, the recommended choice, the network load balancer, supports TCP traffic and allows automatic connection to the EC2 instances in the backend. Question 3. A company has transferred its critical business data to the Amazon EFS file system, which will be accessed by multiple EC2 instances. As an AWS Certified Solutions Architect Associate, which of the following would you recommend to enforce access control, ensuring that only authorized EC2 instances can read from the EFS file system? Please select 2 options from below. 1. Use VPC security groups to regulate the network traffic to and from your file system. 2. Use network ACLs to manage the network traffic to and from your Amazon EC2 instance. 3. Use Amazon Guard Duty to prevent unauthorized access to the EFS file system. 4. Set up the IAM policy root credentials to manage and configure the clients accessing the EFS file system. 5. Use an IAM policy to govern access for clients who can mount your file system with the necessary permissions. Please pause the video and answer, and then check with me if you are correct or not. Hope you paused the video and noted the answer. The correct options are option 1 and option 5 above with below explanation. Explanation. The recommended approaches are to use VPC security groups to control the network traffic to and from your file system and to utilize an IAM policy to manage access for clients capable of mounting your file system with the required permissions. You can control which EC2 instances can access your EFS file system by leveraging VPC security group rules and AWS Identity and Access Management (IAM) policies. Additionally, you may employ EFS access points to manage application access. Access to files and directories is regulated with POSIX-compliant user and group-level permissions. Files and directories in an Amazon EFS file system support standard Unix style read, write, and execute permissions based on the user ID and group IDs. When an NFS client mounts an EFS file system without using an access point, the user ID and group ID provided by the client are trusted. EFS access points can be used to override the user ID and group IDs used by the NFS client. When users attempt to access files and directories, Amazon EFS verifies their user IDs and group IDs to ensure that each user has the necessary permissions to access the objects. Question 4. The engineering team at a social media company has observed that some of the images stored in S3 are frequently accessed, while others remain inactive for a significant period. As a solutions architect, what is your recommendation for building the most cost-effective solution? The options are: 1. Create a data monitoring application on an EC2 instance within the same region as the bucket holding the images. The application is triggered daily via CloudWatch, altering the storage class of infrequently accessed objects to S3 zona A, while frequently accessed objects are migrated to the S3 standard class. 2. Store the images using the S3 standard IA storage class. 3. Create a data monitoring application on an EC2 instance within the same region as the bucket storing the images. The application is triggered daily via CloudWatch, changing the storage class of infrequently accessed objects to S3 standard IA, while frequently accessed objects are moved to the S3 standard class. 4. Store the images using the S3 Intelligent Tiering storage class. Please pause the video and answer, and then check with me if you are correct or not. Hope you paused the video and noted the answer. The correct option is option 4 above with below explanation. Explanation. The appropriate choice is to store the images using the S3 Intelligent Tiering storage class. This storage class is specifically designed to optimize costs by automatically transferring data to the most cost-effective access tier without impacting performance or necessitating additional operational efforts. It operates by housing objects into access tiers, one optimized for frequent access and another lower-cost tier optimized for infrequent access. Under this model, Amazon S3 monitors the access patterns of objects in the S3 Intelligent Tiering, moving those that have remained unused for 30 consecutive days to the infrequent access tier. If an object in the infrequent access tier is accessed, it is automatically shifted back to the frequent access tier. Implementing the S3 Intelligent Tiering storage class is, therefore, the suitable solution for the given scenario. Question 5. The DevOps team at a significant financial services company utilizes multi-availability zone (multi-AZ) deployment for its MySQL RDS database to automate database replication and enhance data durability. The team has scheduled a maintenance window for a database engine-level upgrade during the upcoming weekend. Which of the following correctly describes the outcome during the maintenance window? Options are: 1. Any database engine level upgrade for an RDS DB instance with multi-AZ deployment triggers both the primary and standby DB instances to be upgraded simultaneously, resulting in downtime until the upgrade is completed. 2. Any database engine level upgrade for an RDS DB instance with multi-AZ deployment prompts the standby DB instance to be upgraded first, followed by the primary DB instance, causing no downtime during the upgrade process. 3. Any database engine level upgrade for an RDS DB instance with multi-AZ deployment initiates the upgrade of the primary DB instance first, followed by the upgrade of the standby DB instance, ensuring no downtime throughout the upgrade process. 4. Any database engine level upgrade for an RDS DB instance with multi-AZ deployment triggers both the primary and standby DB instances to be upgraded simultaneously. However, this doesn't lead to any downtime until the upgrade is completed. Please pause the video and answer, and then check with me if you are correct or not. Hope you paused the video and noted the answer. The correct option is option 1 above with below explanation. Explanation. The correct option is that any database engine level upgrade for an RDS DB instance with multi-AZ deployment triggers both the primary and standby DB instances to be upgraded simultaneously, causing downtime until the upgrade is fully completed. Amazon Relational Database Service, Amazon RDS, simplifies the setup, operation, and scalability of relational databases in the cloud. While offering cost-efficient and resizable capacity, it automates time-consuming administration tasks such as hardware provisioning, database configuration, patching, and backups. Upgrades at the database engine level necessitate downtime. Even if an RDS DB instance uses multi-AZ deployment, both the primary and standby DB instances are upgraded concurrently, resulting in downtime until the upgrade process is finalized. The duration of this downtime varies depending on the size of the DB instance. Thanks for watching. Hope you would like this content. Please share and subscribe my channel for more contents on AWS.